All right, hello class. Welcome to this video on the 7.172 practice problems. So we're going to cover the the questions, the practice quiz that is based off of dilations and similarity transformations. So let's go ahead and get started. So for the first question, the first few questions are true or false. A dilation is a transformation that preserves the angle measures of the pre-image. And this is just a definition question, and or a characteristic. Yes, a characteristic of dilations are that they do preserve the angles, but they do not preserve the sides. So if you have this and you transform it, you could enlarge it. The angles stay intact, but the sides do not. So this is true. Leading into the second question, a dilation is a transformation that preserves the measures of the sides. It does not preserve it. The sides do change when you do a dilation. That's actually why it's called a dilation. So that's actually false. Similarity transformation is a sequence of transformations that involves a rigid transformation and a dilation. Remember, to get something to be a similarity transformation is when you're getting from one figure to a similar figure. And in order to do that, you got to do, for instance, you got to translate. So you got to translate this so that it kind of lines up. And then you have to do a dilation to make it larger or smaller. So you got two things that are happening. You need a translation, and a translation is known as a rigid transformation or a congruence transformation. So this is rigid. So you need to have a rigid component, and then you need to have a dilation component to stretch it or compress it. So this is true. This is, in total, this is my similarity transformation to get from one to another to be the same. So yes, this is my similarity transformation. So this is going to be true. So question 4, describe a similarity transformation that maps SQR to DEF. So in this case, they're saying that they're basically saying that these are supposed to be congruent, and so the idea is that you're going to take, for example, in this case, you have to do the transformation to get this to overlap, to get those two to overlap. So perform the transformation here. Like, for example, this first one, it mentions that we want to do a reflection across side QR. So we're going to do a reflection across side QR, and if we do that, then we'll get a shape that looks sort of like that. And so this is going to be QSR now. We'll call it Q prime, S prime, R prime, whatever you want to call it. But take this now, and once we do that, then we want to perform it says perform a translation from Q to E. So now we're going to take this and we're going to translate it to here. And so we got something that kind of looks like that. And then, then we want to perform in this case for my first selection, we want to do a rotation about Q, because this is where Q is now. So if we rotate Q, that will get those to line up, and that's exactly what we want, right? So we want Q to line up here. So we want to do a rotation, and then for the second option, we want to follow it up. So once we rotate this so that they line up, then we want to do a dilation to make it smaller. We want to do a reduction. In this case, we want to reduce it by a factor of a half. So we want to do this. Okay, so those are my transformations that I want to follow up to get those to line up. All right, for the next example, it says describe the relationship between the sides and angles. So type the letters for the side or angle, use capital letters for your responses. So we're just going to label. So it says here, what's the relationship between DE and SQ? Well, we know that DE is is half as large as SQ, and SQ is twice as large. So that means SQ is twice as large as DE here. And DE corresponds to SQ, you can tell because here and here by the similarity statement. And then by the similarity statement, angle Q has to equal angle E here. And similarly, angle R has to equal angle F, and so on. and angle S has to be congruent to angle D. Remember that in a similarity transformation or in a dilation of some sort, the angles are the same. So in a similarity statement, the angles are equal, but these sides are not. Their sides are proportional to each other. In this case, they're proportional by a scale factor of 2. Or in this case, a half, since you're going from here to here. So question 6, write a similarity statement for the given figures. So again, using the information that we know from the two diagrams, we can get these diagrams to essentially line up. And if we get the diagrams to line up, then we can state which ones are similar to which ones. So, okay, so let's go ahead and get these to line up. So if I want to get, say, this to line up with that, so that we can tell which one are similar. What we can do is we can do a let's do a reflection across a horizontal line. So if I were to reflect it across here, I would get something that looks like, so reflect this, so it's going to go like that. If I reflect it, reflect this, so it's going to go, instead of up, it's going to go down, and it's going to be long, of course, compared to this one. And then this is going to go up here, so it's going to go down. It's a reflection, remember. So it's going to reflect down, and then this is going to go up, so it's going to reflect like this. So it's going to look something like that. It's not a very good picture. I'm just, giving you an idea of how it would look like. But it looks kind of like that. And so this is K, this is L, next to that, H and J. So that's a reflection, and then let's reflect that. So you could tell that if I reflect this, those are mirror images of each other about a horizontal line. So I'm going to reflect it about horizontal line. And so I get H, J, and then I get K, again, reflection. And then here I got L. And so that right there looks like that. You can tell. So C has to do with H, D has to do with J, A has to do with K, and L has to do with B. So you can see that A, B, C, D in here corresponds to K, L, H, J. And that is the similarity statement. Those line up. Those are the same measures. The angles are line up to be the same, and that's your similarity statement. Okay, so remember for the similarity statement, the sides don't have to be the same length. They just have to be proportional to each other, but the angles have to be the same. So this angle has to be the same as that angle, and so on. So for question 7, complete the following statements concerning the triangles. So we know that these triangles are similar. We can tell because the angles here are the same, and so therefore these angles have to be the same because they had to add it to 180, and we already know the other two angles. So therefore these triangles are similar. And they have to be proportional too. So in this case, you could tell that they're proportional because 2 times 5 is 10 here. Or let's look at the statement that doesn't correspond to that. It's 2 times 2 is 4, and then 5 times 2 is 10. Those correspond to each other, and they're proportional. Okay, so angle Z is congruent to, in this case, angle A. And then let's do the proportionality here, the proportions here. XY is 10, so 10 is to CB, as YZ is to, in this case, YZ is to AB, and AB is 2. Okay, so, but they just want the capital letters here. So they want you to write AB here. And then 4 is to 8 as 2 is to 5, or 4, sorry. 2 is to 4, based off of those two triangles. And that's my number there, 2 divided by 4. Okay, so just talking about proportions and which ones correspond to what. For the next question, we want to draw an image of this triangle for the dilation with center T. So the center is here. We're going to stretch it from there, and the scale factor is 2/3. So if I'm going to stretch it from there, that means I got to stretch, this that way. Well, in this case, this is a compression. This is a reduction because this number is smaller than 1. So we're not really stretching it. We're actually compressing it. We're making it smaller. Okay, so but in any case, we got the distance from here to here, and we want 2/3 of that distance. So let's cut this into roughly 3 pieces, rather. 1, 2, 3. So roughly 3 pieces, about the same length. So around there. And so then 2/3 of that will be around here. So this is 2/3 of that. So that's shrunk a little bit. And then we're going to go from that center here and then cut that into 3 pieces. So let's see here. 1 and then maybe 2, 3 pieces like that, something like that. It's pretty roughly a rough estimate. And then this here is right around here. Remember, we're just estimating it because we got a multiple choice here. We can actually find the numbers here if you count these squares. So there's 1, 2, 3, 4, 5, 6, 7, 8, and 9 squares here. And 2/3 of 9 is what you really want to do. 2/3 times 9. So 9 divided by 3 is 3. And then 3 times 2 is 6. So you really want to go 6 squares in. 1, 2, 3, 4, 5, 6. And that's actually a pretty good estimate what I did there. So that's pretty funny. So pretty good eye. But in any case, we got this. And then obviously we're going to shrink this part as well. And so we should get something that looks like that. Which is this one right here. All right, and that's how you do dilations from a center. Question 9, use a graph at the right, or in this case in the bottom below. Find the vertices of the image of QRTW for a dilation with center 0, 0 and scale factor of 3. So the center is 0, 0, so we're doing it about the origin. Okay, so it's pretty easy if it's origin and then you're doing a scale factor of 3. So you're doing D3, that's what you're doing. Whereas here, you were doing D 2/3 at point T. So this is harder to do than the origin. Origin's pretty easy. All you gotta do is multiply the coordinates by 3. So if I wanna do the vertices here, all I gotta do is multiply each of the coordinates. So this coordinate is -2 and 4, or 3 rather. So I gotta multiply by 3. So 2 times 3 is 6, so -6, and then 3 times 3 is 9. Very easy. And then R is -3 and 1, so 3 times 3, so it's going to be -9, and then 1 times 3 is 3. Done. And then W is 2, 4, so 2 times 3 is 6, and then 4 times 3 is 12. And then finally we got T, which is 2, -1, 2 times 3 is 6, and -1 times 3 is -3. Okay, and that's how you stretch things in that direction. When you're doing the origin, it's pretty easy. You just multiply each of the coordinates by that number. All right, the polygons given below are similar, but not necessarily drawn to scale. Find the value of x. So we know that these are similar, and so we know, and these are lined up very nicely. So we know that these are in the right orientations for us to compare directly. So we know that x plus 5 is to 18 as, in this case, 5 is to 10, or 4 is to 8. Either one is fine. It doesn't really matter. And then we cross multiply. So we got 18 times 5 is, let's see here, 90, and then you got to multiply this together, 10 times x plus 5, distribute, so we got 10x plus 50 equals 90, 10x equals 40, just subtract 50 from 90, and so x is 4, 40 divided by 10 is 4. So that means that x is 4 here, which makes sense because if these are doubled, then this is going to be 9. So 9 doubled is 18, right? So 4 plus 5 is 9. So that makes sense. All right, the next question, what are the coordinates of the image D3R, where R1, -2 is the center of dilation? Again, it's pretty easy to mess this up, so I would suggest just drawing the coordinates here. So we got R, which is 1, -2, and then we got 1, 2, 3, 1, 2, 3, 4, 5. So this is my coordinate 3, 5, and I want to stretch those. So I'm going to go from here to here. How far is it in the y direction? Well, in the y direction, it's 1, 2, 3, 4, 5, 6, 7. And in the x direction, it's, let's see here, 1, 2 in the x direction. And then I'm going to stretch it by 3. So I'm going to multiply those by 3. And so this will be 21, this will be 6. So I got to stretch this 6 units away from here and 21 units away from here. So So that means from R. Okay, so R is 1, -2. So I got to do 1 plus 6 here. So 1 plus 6, which is 7. And then I got to go up, right? So that's going to be up 21. So I got to do -2 from the R plus 21, which is 19. And that will give me my coordinates. All right, guys, I hope you found this useful. I hope you took something from this. And as usual, I'll see you in the next one.